I would like to wrap up this session with the golden rules of ideal op amps that we've just established. So if you follow these two rules and these two rules only, along with all of the circuit analysis techniques you know up to this point in the course, you can solve any op amp circuit problem. The golden rules of ideal op amps are, number one, that the input currents are zero. The ideal op amp, in which we're always going to work with ideal op amps in this class, they do not draw any current. They draw zero current, and this makes your analysis way simpler. For example, on this last problem, because the op amp drew zero current, we were able to say that there was no drop across R1 and just set VP equal to V1 right away without doing any calculations. So simple. Simplifies the analysis. All right, so the op amp draws zero current. That's one of the rules. That's the first rule. The second rule is what I refer to as the op amp action. Okay, the ideal op amp has an action. It is constantly deciding, think of it like it has a little brain. It's deciding what needs to happen, and it will do whatever is necessary to force VD, the differential voltage, to zero. That is the difference between VN and VP, like we drew here, that differential voltage between these 2 points, this voltage here, the op amp will do whatever it has to make these equal. So in this particular example, what did it have to do? It had to source 500 milliamps of current through this 2 ohm load resistor to then develop a voltage VL that was equal to a volt. So that was the same as V1, so that was the same as VP as this voltage here. That is what an op amp does. That's its only purpose in life. The op amp will do whatever it has to make VN, the inverting terminal, equal to VP. It will do that by sourcing current out of the amplifier, like we saw here. It's coming from the positive 10-volt source going down through the load, and we call that sourcing current out of the output pin. Or it could sink current from the output pin. So if it had to instead pull current from the load, from ground, and then back into the input pin and then down to the minus 10-volt supply, that would be an example of sinking current, and we'll see some examples of that as we go through. This all happens through the feedback path to the input, okay? And so the op amp can only do this action if somehow it knows the difference between the output pin, the input pins, and for it to know that difference means it has to have feedback. And I'll just draw this on here. We'll look at this in much more detail next time, but this node right here, this node in this particular example is the feedback path. It's the path that we provided. We connected that wire there where the output is fed back to the input of the amplifier. All right, so there's a lot of new terminology here. There's some new schematic symbols and new concepts. It'll take some time to get used to, but we'll continue and analyze a whole bunch of circuits, of op amp circuits, using these golden rules and the circuit techniques you know so far. And we'll introduce a bunch of op amp blocks: inverting, non-inverting, summing amplifier, difference amplifier, later on a differentiator, an integrator, and so on. And you will come to learn all these common op amp blocks, and we'll establish their behavior through these golden rules. And I'll teach you how to analyze just arbitrary op amp circuits as well. Again, using just these golden rules.